Hi, for the final episode in Algos in 10, we're going to play a little baseball with abstract hashing types with AHT. It's been such a pleasure this entire summer to basically do Algos in 10 with you guys. I hope you guys now understand algorithms a lot better and can finally ace those leak code interviews. Algos in 10 Season 2 will be much more better, much more in-depth, in which we'll cover some more complicated topics in next year when I graduate Northeastern for Masters. So yeah, enjoy the AHT. We're going to have basically a CRUD, create, read, update, delete, and even patch, apparently, a type of data structure. This is super important for OOP or object-oriented programming topics. So definitely make sure that you guys can not just subscribe, but learn to play ball. The actual baseball all-star game is actually canceled because of the COVID pandemic. But we have a way to simulate it with regards to the MLB The Show. So this episode is sponsored by MLB The Show, where we have basically you managing the AL team or American League team, and then your friend managing the National League or NL team. And there's always a bunch of rules in baseball that you can look up Wikipedia and enjoy. And there's also a tribute back to my database sports camp years when I play baseball and do WASA or science as well. So let's play ball, guys, and go MLB. Oh yeah, make sure to subscribe to my channel. And enjoy finally a sports related, which is my favorite type of computer science problems. So this problem set will be basically one of the longer ones in Algos in 10 because we're basically making an ADT or abstract data type with regards to AHT or abstract hashing type. So we're trying to basically determine a managerial way to determine if the rosters of the baseball are considered actually a good managerial decision, or unfortunately, as of the Red Sox this year, a bad managerial decision. In addition, we will also consider players getting suspended or injured or other roster changes. So put on your GM gloves and enjoy this the finale of Season 1 Algos in 10. So yeah, guys, it's the finale of Algos in 10. I can't believe it, guys, but to begin my first course of Northeastern FSC tomorrow, Foundation Software Engineering. And I'm a bit nervous. It's going to be a difficult graduate course, so I'm glad to end this episode basically on a good note. It really sucks that the pandemic took away the MLB All-Star Game in Los Angeles, but we still simulate it by having the following. If you guys never played the game of baseball, don't worry. We're not going to worry about ERA or averages or home runs or WAR or even any of those type of sabermetric stats. That's for NUTV and those sabermetric people. For tonight, we're going to worry about only three things: the position of the players, substituting players, and replacing players. That's right, tonight, for Algos in 10, you're going to become the GM, general manager of your AL and NL team. So, in the comments below, which one do you like more? American League or National League? And by the way, if you've actually graduated Worcester Academy or been to Worcester Academy Sports Camp, this is how they do things. For that aside, we're going to now actually play baseball in computer science. Oh, by the way, this is sponsored by MLB The Show, which is a great game in terms of, generally playing baseball. And in a pandemic, this is actually really great to play GM in your own baseball game. So in a game of baseball, you have the following. You have 4 bases, of course, and I am doing the best I can drawing them. And the positions are the first base, second base, third base, and at home or the catcher. Then you have the pitcher over here. You have a shortstop. And this is not to scale, but then you have the outfielders. The left field, center field, and the right field. And of course, in the AL, such as Dave Ortiz or Boston Red Sox, you have something called a DH, or designated hitter. And the purpose of baseball is to basically, hit the ball over and win the game in terms of runs, hits, and errors. Sabermetrics aside, we're going to do something called the abstract hashing type, or AHT. And this is going to be a bit of a longer episode, so if you're in for a bit of a longer episode finale, you found the right place. So abstract hashing type is super important and not just leak code by any computer science data structure problem. Now let's think for a second. Let's say it's not hashing. Let's just say this is an abstract data type instead. So pause for a second. What would an abstract data type consist of in this type of problem for a baseball team? I'll show you now when we take a pause. Also, shout out and really big thank you to the MLB. I should be able to play this season given the pandemic. This fantastic job from Robert Manfred. Though my NUTV sports tier is going to roast them a little bit. So yeah, let me show you what the situation is going to be. So we have something called the abstract data type. Generally, for an abstract data type, we have at least two main values, or two main parameters. We have something called the init, which is the initialization of the data type. Now, if you have never done data types before, I have a great reference in the comments below that will teach you what a data type basically is. Essentially, data type is something that stores, like, something in memory. So, for example, in the baseball game, we can store the following in memory. We can store, the player's position. Well, in this case, David Ortiz, I'm going to use as a player because I'm a Red Sox fan and Big Papi is my main man for the World Series. His number, which is 34. Oops, sorry, I did it upside down. It should be number here. Number, which is 34. And finally, for David Ortiz, we have the most important part, his roster position, which is also a value, a number. Continuing onwards, we have also a thing called immutability, or is able to change. So right now we're making the data type to be immutable, or that it's not going to change. That's super important for making test cases if this thing was like a LeetCode problem. It's like basically trying to write test cases. In addition, this problem also requires a little bit of knowledge in terms of key value pairs. So it's a bit of a dict, key value pairs in the dictionary. So we are going to use Python dictionary to store the values of each player's position, number, and roster positioning inside the lineup. We're using Python dictionary as basically our store for the data structure. Now, let me quickly show you guys how this entire data structure would work. And by the way, this data structure could also have null values. So by default, these are all basically defaulted to null, which is super important to understand once you actually have a general idea what we're trying to do for the problem. So now finally, with some general background being taken care of, we can go to the rather convoluted AHT problem set. So what is an AHT? An AHT is called an abstract hashing type. This is not a real data type, but it does get close to what we call a secondary data type. So the real data types we have, of course, are a bunch of arrays. We have strings. We have trees. We have hash tables, which is something we are going to use, and it's something called a heap, which is important, which is what we use from the Charlie and Chocolate Factory meeting. So this entire problem set puts everything together, minus the end programming from Algos intent. So this is the grand finale. Like Thanos, this is like all the Infinity Stones put together for the entire problem set. And the AHT has the following. You are basically determined to be the AL manager of your team. So you basically control the American League for you. And then you have a friend who loves baseball, controls the NL, who is also the manager. There's no commissioner because that's Rob Manfred. In addition, you also have both starter and reserve lineups. So if you're a sports fanatic, this should make pretty much all sense for you. So you have reserves and starters. To keep things simple for this problem set, we're going to keep them equal number of reserves and starters. Typically in the MLB All-Star game, there's 17 reserves and starters. So your total is 34. You're like, whoa, Jason, that's a lot of players. Don't worry, that's where the hashing table becomes good. Because if you remember, hashing table has O of 1 runtime pretty much anything, including even storage if you memorize it. You'll see now why we're using hashing table in the abstract hashing type. when we get to the solution of the problem. So now we have a solution of a problem basically built up. We can now start beginning to have a general approach. So since we have a lineup, right? We have a lineup of players. Let's just say, for example, we have 3 players. One from the Boston Red Sox. So we do it as such. Boston, DH, number 34. Then we have one from, I know, I'm sorry to say this, New York Yankees, you know, classic guy. He's retired already, but we'll just say we put him in here. Derek Jeter, New York Yankees, shortstop, number 2. And of course, you know who I'm gonna put the final one, right? Big Mr. Big Babe Ruth. The great Bambino, Babe Ruth. Boston and New York. He is basically a pitcher, and he is, let's just say infinity, because Babe Ruth is awesome. So in this data type, we basically have a roster of players named 1, 2, 3, ... n. This is not to scale, this is just to show you how the data type looks. So that means we should be able to do something to the data type, like, you know, add players or update players if they get injured or suspended, or if they're stupid enough like Bryce Harper to get ejected even, then sure. So for that, we're going to introduce something data type in databases called CRUD. Create, read, update, delete. This is super important to understand for the AHT. So you can see this is a very complicated problem. This was actually nearly LeetCode hard, actually. By the way, this problem set in my LeetCode preparation this summer. And also preparation for FSC, the Foundation of Software Engineering course I take at Northeastern. It's almost into machine learning almost, in terms of like storing data sets. This is why I put this in the finale, because it's the most difficult. So CRUD is really a very simple way to do things. But there's one more function called patch, and that's where a lot of people don't understand how this works. It's similar to update, except for patch, you do also something else. You do a patch on your previous update value to basically keep a deep copy of the previous value. And deep copy means you basically keep the same exact attribute, as opposed to shallow copy, which is like you basically keep only the reference. So once again, if you don't know what call by reference, call by value is, suggest you look in the comments, the notes. This is a fairly complicated concept. Do not get too much into this, because this gets more to databases and machine learning. But CRUD is basically the general data structure we're going to use to store the abstract hashing type. Now, all database and roster stuff aside, time to finally build the general approach and write a bunch of Python pseudocode for the solution. As always, with any solution in Algos and 10 interviews or the FSC course I'm about to take, you must make sure you have a concise design. So our design is the following. We begin with initializing the AHT. So we have class AHT, which is the abstract hashing type. I'm using Python pseudocode. You can use anything you want, but Python's the easiest to understand. So we have something very simple, which is the init function. Initialize the values. So within the init, we have the following. We have self.player, each player of the roster. Oh, I almost forgot. You also have 2 outside classes, class AL, class NL, that are called abstractly outside. They're abstracted away from the main function. That's a good design approach to have, because you don't want to have too much code repeated in there. You have a position to player, then self.name, and finally self.value. And that's it for the init. Also, just to store the player names, we're going to use something called a max and min heap. For keeping things clearly, I'm going to use the AL for the max heap and NL for the min heap, just to keep things clearly. And we're also going to consider that maybe the plus by 1 case, the left child, right child, are substitutions of the tree, if you're going to put this all in a tree. Basically, when the player is injured or ejected or just not available, we're going to use the min-max heap to justify for those issues. Now let's see how we actually build the rest of this entire thing with the min-max heap and also with the Python pseudocode. In addition, we're going to use the word heapify up and down, which means we're going to try to basically move up and down the players via a heap. Because trying to move down, up and down in the AHT is too costly. You have to do a linear search, and that's already not good for Commissioner Manfred. Oh yeah, fair note of warning, by the way. Don't pull a Houston Astros. Do you know why? Because technically this code is available on LeetCode, this type of solution, because it is an actual LeetCode design solution. I just jazzed it up to make it MLB-like. Rule of thumb, whenever you have something like this, do not pull a Houston Astros. Don't pull an Astros and cheat. Don't pull an Astros and cheat in this. Like, honestly, cite your sources, like, make sure you know what you're doing. Because that's one of the biggest ways you can fail the interview and also get in trouble in class. And you know, in a pandemic semester, you don't want to get in trouble in class. With that warning aside, now I'm going to show you very quickly, in hopefully 5-minute increments, how to actually get rest of your functions working for our AHT, abstract hashing type. Oh yeah, we switched modes, vertical mode, because this thing will take a lot of space. So we switch to vertical mode now. So let's do our first function. Whoops, that's a bad pen. First function for the abstract hashing set. Def insert player. So this is like basically the GM telling you, hey, player X, Y, and Z, you ready to go into the roster for AL or NL? And of course, your parameters are self because this is recursive, and then the player. So before I fill out the rest of the function, you should try to fire up a Python terminal or do on paper what would this thing do. And if you guess that you can actually do AHT.append or the heapify up, you already know what you're doing. You're a good GM. Because that's exactly what we're supposed to do. We're going to use heapify to put in the players. So try heapify up, just to simply put up the players into the roster, given the player and the position. This is pseudocode, so it's not really meant to be compiling. It's just trying to show you just generally how the design works. And of course, always append the player if you're going to do that as well. AHT.append player. But what happens if a player does not want to play due to COVID, or I don't know, they're just not ready to play baseball, or they want to go for social justice? An NBA boycott joke. Well, they can do except exceptions. So you can do except player error, which is like another fancy way of saying that the player cannot play in computer science. And for me, I'm going to make it really simple. Just say print player, and we use this %s to represent substituting a string. Player not in roster. So that's it. That is the insert. The good thing about this AHT data type is that you can basically repeat this 4 times in a row and it'll look good. But there's a better way to do this. You'll see very quickly in the is player in roster, a Boolean true-false function, why it's not very good to actually always copy to try except, because there's some edge cases. So let me show you right now how we write the is player in roster function with a key value pair. So here is the second function of our really long AHT. This has 5 functions total. You can imagine how long it took me to figure this out on an actual LeetCode. A whole day. So if you want to go for Fortune 500s or the big boys, you need to know how your data structure is cold to pull this one off. Even in my co-op, I don't think I've actually had to do this type of coding yet. But it's good practice though. So we have the function is player in roster, which you have in this case a key to determine your player roster. This is from the abstract hashing type concept of using keys and values, as I just mentioned. So once again, we do a try. But this time, the try is a little different. We basically have to find if the player is in the roster. So if player of the key, this player can also be a data type of itself, equals true, which means you found a player in a roster. And of course, after in parentheses, because it's Python pseudocode, you return true. That's really simple. Here's what gets a little tricky. you return false right away immediately, because then you would not find him. It's not good to use if else too much, because it'll then clutter your code, and that's not what you want to do for like a good design. Then you have an else right away, an else. And this one gets a little bit long, so I'm gonna write really small here. Then you're gonna return the AHT contains function, which is another helper function that tells you whether you have the player inside your roster. And you basically return a conditional here. If AHT contains the key equals a player of key, then you're golden. Your player is in the roster. Otherwise, he dipped and did something else that is not MLB related. And then finally, if your player just does not care about baseball or just is sick or whatever, you'd use the roster error, which is another type of error found in AHT. And then you do another printf, which is really simple. Printf, this time we use %d to represent integer. %d key, which is your value. Not available. Oops. I'm supposed to put the comma here and the quote here. There we go. And there's no period in Python. So yeah, that's it. That's your is player and roster. Very, very simple. Here's where things get a little more complex. Substitute to player. You have to basically substitute multiple parameters. This is where you want to be careful, and this is why I'm glad I'm not using C, because you have to worry about pointers and then allocations. It becomes a mess. Python is way easier to do this. So your third function is substituting the player. By now you should understand what this is trying to do, right? It's going to be the update of the CRUD. The isPlayer and roster technically was a patch, but I wasn't really using it as a patch. There's another function to help you use it as a patch later. It was more of a read, actually, the isPlayer and roster. It was trying to read in the roster whether the player is available or not. In this case, you take three parameters. Self again, of course, player 1, and player 2. So trying to basically substitute one player for another in the roster. Yeah, sure. And then, very simply, if the players are available, you do a try, and you have a function called replace, which basically replaces player 1, player 2. This is all pseudocode, so once again, don't expect this to compile. Just notice this is the type of thinking you will have to have in the interview or in the design course, is to have this mindset of data structure, data structure, data structure. Otherwise, you have an except, and this time you have a very common Python thing called substitution error. This is an actual Python error, look it up. This is not made up. And this one's a bit of a longer printf statement, so we're going to do the following. Name %s, which is going to substitute a string, and this is the first name, and value %s again. So this is where things get interesting. And value is really simply just the value of the player 1. So we're going to do the following. We're going to do basically val1, or value of player 1. And that's another Python construct. And then finally do it again for player 2. Sorry, I keep messing up commas and quotes. This is a long Labor Day. Player 2. And then finally, we just do again, substitute the value of player 2. Now you're wondering, this is a really bad design, right? It's a very bad printf statement. So we're going to now completely change it. This is an example of refactoring the code. It's not a good design, I agree. What a good design should have is to put them together. So here's what I should have as a design. Printf name of player 1, so name of P1. In this case, it'll be pretty simple. It'll be just player 1. And value, so this is another simple %d. So then we'll just do value of player 1, which is what we had before. And then we do again, name of player 2. I'm abbreviating this actually of space. Percentage S, player 2, and value of player 2 is not available. This is what happens when you don't think of design ahead of time. You run out of space. Not available. Yeah, this is a bit cramped, I'm sorry, but this is this is the entire solution now for the substitute player. You have basically a try, replace value method, and accept a big long printf error that says basically player 1 and player 2 names and values not available. So yeah, this is just barely reaching the 5-minute mark. The 4-minute 20 mark in terms of each function. So I'm gonna go much faster right now to do delete player and change player position. All right, deleting player is back to easy mode because you have to only worry about simply removal and heapify down. So def, oh my God, def delete player. And once again, you have self if player as parameters. Always make sure you keep track of your parameters. Very easy to get lost and debugging nightmare otherwise. So if a try statement, again, heapify down. Player and position. That means you basically move the player out of the roster from the AHT. And then you just do AHT dot remove player. That's really simple. Otherwise, the accept is also very simple. It's just gonna be print player percentage %s, which is, I hope by now you know that means string, not in roster. So yeah, this is a weird data structure because actually the insert and delete is super simple, but all the other operations are very complicated. That's when you know this data structure is good runtime. When you have insert and delete simple, but the lookup actually fairly complicated. But don't worry, it's not going to go past linear time, as you'll see soon once I'm done with this thing. And then I'm going to finally show you change player position. We can finally go to runtime. This is a long Algos in 10, but like, this is the finale, and I really want to go through MLB in a computer science. Just to save some time, I already wrote the change player position, at least the parameters, self player position. So do another try. And this time it gets a little tricky, so I'm gonna go a little bit more slower. You have to call your helper method substitute player already from earlier. So you're using helper methods already in the AHT. So we have to actually call the substitute player method from the AHT. So self player, or player 1, player 2, doesn't really matter. It's just parameters. And then you also then basically do an input. So you do a player at the value of your position, and this is a Python thing called input. So you do the keyword input, which is basically taking in a string input, new position. Maybe for a bonus video, I can actually give a coded out version of this, but that's gonna be probably later in near the end of a semester in December, biz school, you know? Then also we have new position as a parameter, and this pen started to wear out on me. This is how taxing this Algos in 10 finale is. My pen started to actually wear out. Equals player of the position. And then finally we do a printf, just to say that the players are there. So player, percentage %s, comma player, and then position, percentage %, comma position. That's it. Oh, careful. You didn't actually find out what's the position yet. So you have to be careful here. So you have to say position, percentage %s, and then finally position again. And I'm sorry, this is really badly written here. Position, there we go. So that's your printf. Ignore that squiggly. Since I'm running out of space and running out of marker, I'm going to switch to a complete new marker and new space for the rest of the function. So here's part 2 of a super long change player function. And I'm switching to red because that's the only marker I've left that's not dead right now. So yeah, part 2 of the player position functions. We have the except, and once again we call substitution error. Which is once again telling me you have an error of substitution. So you do another long printf statement. Printf, actually no, printf is not right. That's from C. My apologies. Just do print. Player %s. I know this is getting really boring, but like this is how you're supposed to do really good exception errors, not the gibberish or the jargon that the compiler spits out at you all the time and makes you not like your life whenever you're debugging. Cannot be changed in position. For position s. And there we have it. That is your entire really, really long, probably like this on paper, 3-page long pseudocode of the entire AHT. And yep, there we go. That is the AHT. So if you want to test the AHT, you could do really simply def main, which is the main for Python, AHT equals new AHT. AHT itself as a class does not take any parameters. And then just for fun, you do your test over here, which you could use either asserts or accepts or anything in Python documentation that lets you testing. But this is algorithms, not design, so we're not going to do any testing. So let me do quickly the runtime analysis and include also the space analysis and one little caveat to wrap up this Algos in 10, the whole summer with Jason Liu, episode 10. As you can see, we're back in landscape mode. So we're going to do a really, really short runtime analysis. This is one of those rare algorithms that takes forever to write the actual algorithm, but runtime takes like maybe 5 minutes. So let me just show you what the runtime is. It's O log n, because we have essentially the following. We have heapify up and down from the min heap, max heap, which is really trivial heap functions. We also have O of n for up to n positions in the MLB roster. Technically 2n because of AL, NL, but we're gonna amortize it to, n because of complexity. And finally, we have O of 1 for each of the CRUD operations in AHT. Because we're not really doing anything like storing or we're just really just checking and adding and deleting stuff and updating stuff. That doesn't really take any more than O of 1. These are called, for my algo class, simple operations. Things like dynamic programming and graphs are called complex operations. So let me now get to the total runtime, which is O n log n, but there's a caveat to how it's going to be run. So here's the total runtime. O n log n, super efficient AHT. Permission of Manfred, your professor in computer science, would be very happy. This is linear log. But there's a caveat to this. This is assuming you have a full roster. If in the case you don't have a full roster, it's only O of log n, because then your roster would be missing. If that is the case, if you have a lot of people missing in your roster, you can do the following. You can amortize the max and min heap operations to O1 to shave off some more time. And what do I mean by amortize? So basically you try to determine, this is a new type of notation. You have omega n, which means you have the biggest bound that is basically linear. And that will reduce this quickly into something that's less than linear for runtime. Pretty good if you want to basically store the entire MLB ESPN roster for the AL and NL teams. And finally, for space, you have ON because it's for the entire roster. So overall, it's a pleasure to do Algos in 10 with you guys. I hope you guys learned a lot about algorithms this summer. And if you're not a computer scientist, you'll see how come algorithms are not that boring or just memorizing CLRS or doing LeetCode. There are great ways to learn algorithms online. Some great resources are LeetCode, HackerRank, Geeks for Geeks, if you can understand some of the comments, and also Stack Overflow. So yeah, this is for the finale of Algos in 10, Season 1, with Jason Liu, Episode 10, AHT, MLB The Show, Abstract Hashing Type. Thank you very much and have a safe and socially distant semester.